Good evening. I'm Kadija with the Newton's News Network. Tonight, a mystery. Someone stole Newton's three laws of motion from science class. We're sending our top reporters to investigate. First up live to Reporter 1 at the scene. Thank you. I'm here where the first clue was found, a museum display that didn't move, even when the lights went out. Newton's first law, also called the law of inertia, states an object at rest stays at rest, and an object in motion stays in motion unless acted on by an unbalanced force. With this example, you will see that the car stayed at rest until I applied a force, which in this case is the tap. That is inertia, the tendency to keep doing what it's doing. This clue shows that the thief exploited inertia. The jewels sat in place until the thief applied the right force to move them without setting the alarm. That's why inertia is dangerous when you don't account for it. On to you, Ethan.
Thanks. I'm at the lab where forensics teams tested how the thieves moved the loot. Newton's second law says force equals mass times acceleration. This tells us how an object's acceleration depends on both the force applied and its mass. I will now demonstrate how two balls with different masses roll when they have the same amount of pressure applied to them. With the same push force, the lighter object speeds up more because acceleration equals force divided by mass. More mass equals less acceleration for the same force. For the second demonstration, I will show two balls falling with different masses fall. Vertically, gravity gives the same acceleration to all objects. Gravity acts equally on all masses in free fall. Back to you.
Live from the getaway scene, Newton's third law, which states that with every action there is an equal and opposite reaction. This means that when an object exerts force on a second object, that second object exerts the same force back onto the first object, only opposite in direction. Allow me to demonstrate. In this direct example of Newton's third law, you can see me sitting down. The action in this example will be me pushing the chair, and the reaction will be the equal and opposite force that launches me backwards. At the heist, when the thief pushed off the display case to leap to the other side, the display exerted an equal and opposite force which launched them, and it launched them backwards. But it also caused the thief to recoil and stumble when they hit a second wall. And that stumble gave a nearby guard the opportunity to tackle the burglar. There you have it, folks. That's how Newton's third law played a part into this heist. Back to you, Kadija.
There you have it, folks. A solved mystery. Thanks to Newton's three laws, inertia, force, and action and reaction, each law named, explained, and demonstrated on scene. Special thanks to our supporters and to Bill Nye for reminding us that science helps us explain the world, even crimes. This had been the Newton News Network. I'm Kadija Quena. Stay safe, stay in motion.